Okay, we shall start the today class. The previous lecture, we have completed static system and dynamic system, and linear system and non-linear system. Okay, static system meaning the output of the system at any time depends on the present input only. That is static system. Dynamic system, the output of the system at any times depends on present input as well as if there is any past input and also future input, then the system said to be a dynamic system. Okay, so static meaning only present input. Y of t represent or y of t depends on only the present input. That meaning x of t term must be there in the expression. Dynamic system, your y of t expression, it may have x of t or x of t minus t naught term or x of t plus t naught term. Okay, if these term, if any one of these term available in your y of t expression, then that system is a dynamic system. Output depends on past input as well as the future input. This is static and dynamic. And next we completed causal and non-causal. Causal and non-causal. Causal system, y of t, it may depends on present input as well as past input. X of t minus t naught. If expression has this kind of term, then it is a causal signal. In your y of t expression, if you have x of t plus something, that is the output of the system depends on the future input to the system. Okay, so the future input to the system, definitely x of t plus some term will be there. Then it is a non-causal system. Then we discussed very important system, linearity and non-linearity. So we have taken a system which has a transfer function of t. Let assume our input is x1 of t. The system gives some output or response y1 of t. The y1 of t equal to transfer function of x1 of t. Suppose if you multiply your input signal a x1 of t, then the system output should be equal to y1 of t equal to a into transfer function of x1 of t. Okay. Assume x2 of t input to the same system. System respond or the system gives an output y2 of t. It would take y2 of t is equal to transfer function of x2 of t. System will do some process on the input signal, then it will give output y2 of t. So generally we represent a transfer function of x2 of t. Okay. Suppose if you multiply input x2 of t with a factor, with a constant, let's say b, now your system output y2 of t must be equal to b into transfer function of x2 of t. Okay. The scaling property. Suppose I'm giving my input x3 of t. My x3 of t is equal to a x1 of t plus b x2 of t. Assume my input x3 of t to the same system a x1 of t plus b x2 of t. My system response is y3 of t. This y3 of t should be equal to a into transfer function of x1 of t plus b into transfer function of x2 of t. Okay. Or we can say that this y3 of t is equal to a y1 of t plus b y2 of t. Okay. Or in this example, in this example directly. We assume like this: x3 of t equal to y3 of t, px1 of t plus bx2 of t, your y3 of t equal to, sir, ay1 of t plus by2 of t. In this way. Or if you give x1 of t, if you give x1 of t plus x2 of t input, then your output should be equal to y1 of t plus y2 of t. Okay. So this principle called as superposition principle. So a system is said to be a linear system if it is satisfy the superposition principle. What do you mean by superposition principle? It must satisfy the additive property. Additive property meaning x1, y1, x2, y2. If I give x1 plus x2, my output should be equal to y1 plus y2. That is additive property. Second one, homogeneous property or scaling property. Suppose if my input is ax1 plus bx2, my output should be equal to ay1 plus by2. That is the homogeneous property. If these two properties are satisfied, then we can say that particular system is a linear system. So this is the concept. So for problem solving, how to implement this simple logic? So already two problems we solved. So we'll start the third problem today. Identify whether the given a continuous time system is linear or non-linear. Same procedure we have to apply for discrete time system also. So y of t equal to e power x of t. If you give input x of t to a continuous time system which has a transfer function t, your output y of t is equal to e power x of t. So whatever input you are applying to the system takes e raised to that particular input. That is the output of the system. So the nature of this or the transfer function of the system is e power. Whatever input, the output should be equal to e raised to that particular input. So this is the given system behavior. Now we have to check that particular system is linear system or non-linear system. Very simple thing. Let's assume our input is x1 of t. System response is y1 of t. Let's assume our input is x2 of t. At that time, the system responses is y2 of t. Assume the system input is x3 of t. What is x3 of t? x3 of t equal to ax1 of t plus bx2 of t. And our system output should be equal to y3 of t. What is y3 of t? ay1 of t plus by2 of t. So from this basic equation, so we are going to replace x3 of t by ax1 plus bx2. Step 1. Okay, step 1, replace x3 of t by ax1 of t plus bx2 of t. Okay, then the equation A now becomes y3 of t equal to e power ax1 of t plus bx2 of t. Okay, that means e power ax1 of t dot e power bx2 of t. Can you write like this? So this will be equal to e power ax1 of t plus bx2 of t. Let's say this is equation number 1. Now, in the basic equation, replace y3 of t, correct? Replace y3 of t is equal to a y1 of t plus b y2 of t as per the superposition principle. So we know that a y1 of t is equal to what? In this example, y1 of t equal to e power x1 of t. A e power x1 of t plus b y2 of t equal to e power x2 of t. Replace equation A. Let y3 of t equal to a y1 of t plus b y2 of t. So y1 of t we derived, y2 of t we derived. Now consider this expression as equation number 2. Now check equation number 1 and 2. If both are equal, then the system is said to be linear system. But in this example, e raised to a x1 of t dot e raised to b x2 of t. Here e power x1 of t plus b e power x2 of t. This is entirely different. So equation 1 is not equal to 2. Therefore, the system is non-linear system. Okay. So like this, if any problem given, very simple expressions or the expression in terms of differential equation, you replace entire equation wherever x1 x of t y of t is there, you replace all by x1 y1, step 1. Next, all the same expressions, all y of t x of t replaced by y2 x2 term, then same expression replaced by x of t y of t replaced by x3 of t y3 of t. Now consider this particular equation is the basic equation. In that equation, substitute x3 of t equal to a x1 of t plus b x2 of t. That is the equation number 1. In the basic expression, apply the superposition principle. If x3 of t should be equal to a x1 plus b x2, our y3 result should be equal to a y1 of t plus b y2 of t. Okay. Then substitute your y1 of t in the given problem. Substitute your y2 of t in the given problem. Check for equation number 1 and 2. If both are equal, it is linear system. If not equal, then it is non-linear system. So I hope you understand now clearly about linear and non-linear and how to verify this linearity property of a particular system. Right? So static, dynamic, causal, non-causal, linear and non-linear system. Next one. Time invariant or time variant. Time invariant system and time variant system. In short form, TI, time invariant, the time variant system. Okay. So as a practical example, suppose we have a RC circuit. RC. So here is the input source. Let assume here we are measuring the output. So this is in this example, this is X of t and this one is Y of t. System level representation. Okay. For a fixed value of R and C, we are doing some experiment today. And tomorrow we come and using the same value of R and C, we do some experiment. So we will get the same output. Unless R and C, the properties of R and C is not changing. Okay, for a fixed value of resistance and capacitance, if we connect this particular circuit in the breadboard and we are forcing some input and measuring the response of the system, and tomorrow if we come and we'll do the same experiment, there won't be any change. That is time invariant system. Okay, that is the actual meaning of time invariant system. So as per the definition from your textbook, Let assume a continuous time system. Same thing will be applicable for discrete time also. If I give some input x of t, a system response is y of t. System response is y of t.
సార్ వాయిస్ స్లోగా వస్తుంది సార్.
So a continuous time system, let assume my input is x of t, the system response is y of t. Okay. So graphically, I give some input like this. Just an example. My system output t versus y of t will give like this. Okay. Let assume like this. Suppose if my input is delayed, by the time capital T, so input is delayed by the time capital T, my output also will be delayed by the same amount of time capital T. Then we can say this particular system is time invariant system. We give some input, the system responded for a particular input. So y of t equal to transfer function of x of t. Suppose my input is delayed by some amount of time. My output of the system also delayed with the same amount of time capital T. Then we can say, then the system is said to be time invariant system. Then the system is said to be time invariant system. If this property is not satisfied, then the system is said to be time variant system. Time variant system. So this is a definition of time invariant system. But how to proceed the problem with this concept? How to proceed the problem? Because linear, non-linear, I have told one simple technique like this. To solve this particular problem, whether the system is time variant or time invariant. So two conditions we have to check for the given expression. One is x of t to the system. X of t to the system. System gives some output y of t. So assume the y of t is delayed. Assume this y of t is delayed. Assume the y of t is delayed by t naught. Okay, this is expression number one. Whatever expression given y of t, in that equation, all this small t replaced by t naught. That is the meaning of this particular step. This is equation number one. Next, assume your input is delayed by t naught first. Your input is delayed by t naught amount of time. X of t minus t naught. And then this input applied to the system. Now you will get one y of t. Now you will get one y of t. Let's say I am y dash of t to avoid the confusion. X of t to the system, my output is y of t. To check time invariant properties of the system, we need to obtain two expression from the given y of t expression. From the given y of t expression, we need to get two expression. One is replace all by t minus t naught. This means the output of the system delayed by t naught amount of time. equation number 1. Second expression, your input only delayed by t naught. In this expression, wherever x of t is there, those x of t replaced by x of t minus t naught. Okay, then you will get one expression, that is y dash of t, equation number 2. If these two equations are equal, then the system is time invariant system. So this is a basic idea to solve the problem, to identify whether the given system is time invariant or time variant system. So if you solve some problem, you will get a clear idea. So in that problem, we are going to write y of t minus t naught, or instead of y dash of t, some textbook follows y of t comma t naught. Okay, remember, y of t minus t naught represents your output is delayed by t naught amount of time. Input directly applied to the system, you are getting y of t. Assume your y of t is delayed by t minus t naught. That is y of t minus t naught. Y of t comma t naught, or y dash of t. This represents your input itself delayed by t naught amount of time. Then apply to the system, then what is the output? If these two are equal, then the system is time invariant system. Okay? So don't worry, we'll solve the problem, then you'll get a clear idea. Example 1, y of t equal to t times of x of t. Identify whether the given system is time invariant system or time variant system. So what I told you, first, assume your output of the system delayed by t naught amount of time. That means in the given expression, y of this t replaced by t minus t naught. So in this expression, wherever t is there, all t's are replaced by t minus t naught amount of time. Yes or no? Y of t equal to t of t. Y of t minus t naught represent what? In this equation, wherever the small t is there, all the small t replaced by t minus t naught. Let's say equation number 1. What is the second one? Y dash of t, or y of t comma t. In this example, t naught I am using. Then I will use t naught, no issue. Okay. What it means? Output of the system, output of the system due to delayed input, due to delayed input. So delayed input meaning wherever x of t is there, that x of t replaced by x of t minus t. Okay. Expression 1, output of the system delayed by t naught. Okay. Second equation, output of the system due to delayed input. Do you understand the concept now with respect to this diagram? I'm assuming my y of t delayed by t naught amount of time, equation 1. Second expression, assume your input is delayed by t naught amount of time and then apply to the system. Now output, let's say y dash of t or y of t comma t naught. If these both equations are same, then it is time invariant. In this example, t minus t naught, x of t minus t naught. Here it is t of x of t minus t naught. Therefore, the system is time variant system. Therefore, the system is time variant system. So I'll give one example for time invariant system. So before that, we'll solve one more problem. y of t equal to x of t square. Y of t equal to x of t square. Now, how to check this? I told you output of the system delayed by t naught amount of time, or some textbook follows capital T. Hmm? Output of the system delayed by a time t. So wherever the small t is there, that all the small t replaced by t minus t. This is equation number 1. Step 2. Output of the system due to delayed input. Due to delayed input. Wherever x of t some informations are there, that is delayed by t naught. Your x of function, your entire x of function delayed by t amount of time. Okay, this is equation number 2. So equation 1 is not equal to equation 2. Therefore, this is time variant system. Output due to delayed input. Delayed input meaning whatever x of function, that function delayed by this amount of time. You should not replace this t by t naught. Your x of function, whatever x of function, that will be delayed by this much amount of time. Okay. This is a little bit confusing for the student, but you have to solve clearly. T minus t represents your output is delayed by t. So you have to replace all the small t in the expression by t minus t. T, y of t comma t represent output of the system due to delayed input. So x of function, wherever the x of function is there, that function delayed by t amount of time. So I'll give one example for time invariant system. Let assume y of t equal to e power x of t. Let assume y of t equal to e power x of t. Identify whether the system is time invariant or time variant system. So what I told you, the output of the system delayed by t. That meaning in this expression, wherever the small letter t is there, all this t replaced by t minus t. Equation number 1. The output of the system due to delayed input, meaning wherever the x of term is there, that x of function delayed by minus t. So in this particular system, output of the system delayed by t amount of time, that is equal to output of the system due to delayed input x of t minus t. So 1 is equal to 2. Therefore, this system is time invariant system. Similarly, for discrete time example, y of n equal to x of n plus n into x of n minus 1. Identify whether this particular system is time invariant system or time variant system. So capital T is used to represent the delay time in CT, continuous time systems. Here we use K n minus K. Assume output of the system delayed by k unit of time, that is n minus k. In this given expression, y of n replaced by n minus k, what did this mean? In this equation, wherever the n is there, all n is replaced by n minus k. This n replaced by n minus k. Okay. X of n minus k plus n minus k x of n minus k minus 1. Equation number 1. Now, my system, my input itself delayed by k amount of time. Now I am applying to the system. Let's say the system output is y of n comma k or y dash of. Second expression. First expression, my y of n itself delayed by n minus k. Second expression form by assuming our input is delayed by k amount of time and then apply to the system. Now our system represented by y of n comma k. So in the given expression, wherever x of n term is there, that x of n function delayed by k amount of time plus n x of n function. This is x of n function. X of some function available, let it be. After that, you put minus k. So this is equation number 2. Check. N minus k, n minus k. Okay. X of n minus k minus 1, x of n minus k minus, okay, minus 1 minus k. These are okay. But here n minus k is it. Here n only available. So equation 1 is not equal to equation. Therefore, the system is time variant system. Therefore, the system is time variant system. Okay. Problem number 4. Last problem. One more problem. In discrete time, time invariant or time variant. Let assume y of n equal to x square of n minus 1. Identify whether the system is time variant system or time invariant system. Equation number 1. Assume our output of the system is delayed by k amount of time. Y of n, this expression. Y of n minus k, wherever n is there, that n replaced by n minus k. Okay. Now, assume output of the system due to delayed input. So delayed input meaning the x of function. Wherever the x of function is there, in this problem, x square of n minus 1 is the x of function. So minus k. So for this example, equation number 1 and equation number 2 both are equal. Here it is x square of n minus k minus 1. X square of n minus 1 minus k. Both are equal. So 1 and 2 both are equal. Therefore, the system is time invariant system. Okay. So understand these particular blocks. For verification of the system, whether it is time variant or time invariant, x of t to the system gives output y of t. Assume our y of t is delayed by some time. Equation number 1. Now second expression, assume our input to the system x of t itself delayed by the same amount of time. Now system responded some output. So this output should be equal to this output. Then we can say this particular system is time invariant system. Okay. So linear, non-linear, time invariant, time variant. That's very important because it involves some steps. Static, dynamic, causal, non-causal. By looking at the expression itself, you can easily identify. One general question to you. Y of t equal to x of t square, or y of t equal to x square of t. Okay. Y of t equal to x of t square, y of t equal to x square of t. Identify whether the given system, which is characterized by the equation y of t equal to x of t square, y of t equal to x square of t. Check whether the system is static, that is memoryless system, dynamic, that is system with memory, and causal and non-causal, linear, non-linear, time invariant, or time variant. Okay. Identify whether the following systems are memoryless, or causal, or linear, or time invariant. What is static dynamic? Let's say first problem, y of t equal to x of t square. Is it static system? Can anyone comment on this? What is static system? Output of the system at all the time depends on present input only. Then the system is static system. By looking at this equation, can we write whether the system is static dynamic directly? Please respond. Otherwise, I'll call the number now. L45. L45. Are you there or not?
Yes, sir. Yes, sir.
Tell me. Is it static system? You're not listening the class? Substitute t0, x of 0. Substitute t minus 1, x of 1. Substitute t minus 2, x of 4. So at present time t0, it depends on present input x of 0. Fine. With respect to t0, fine. But when you substitute t equal to minus 1, the system output depends on future input, because it is 0, the minus 1, 1. At t equal to minus 1, t0, t1 are future input to the system. Okay. At t equal to minus 2, the system output depends on the future input x of 4. If you substitute y of 1, x of 1. Now here it is satisfied. You substitute y of 2, x of 4. Present time t equal to 2. But the output of the system depends on future input. That is t equal to 4. Okay. So this is dynamic system. This is dynamic system. So x of t square, x square of t, both are different. Okay. Same y of t equal to x square of t. This is static system. How? How it is static system? T0, x square of 0, y of minus 1, x square of minus 1, y of minus 2, x square of minus 2. At all the time, or y of 1, x square of 1, y of 2, x square of 2. All the time instant, the output of the system depends on present input. Y of 1, x of 1, y of 2, x of 1. Therefore, this is static system. Okay. So x of t square is a dynamic system. X square of t is a static system. Then causal, non-causal. If the output of the system depends on present input as well as past input, then it is causal. But in this example, y of 2, at t equal to 2 time instant, the output of the system depends on future input x of 4. So this is non-causal. This is non-causal system. In this example, the output of the system always depends on present input. Causal system meaning output of the system may depends on present input as well as past input. But in this example, all the time instant output depends on present input only. So this can be example for causal system. Remember, all static systems are causal, but all causal systems are not static. Because causal system definition, present input as well as past input, both are allowed. But static, only present input. So all static system can be causal system, but reverse is not true. Okay. So two things completed: causal, non-causal, static, dynamic. We completed. Now check whether it is linear or non-linear. X of t square, y of t equal to x square of t. Y1 of t equal to x1 of t square. Y2 of t equal to x2 of t square. Y3 of t equal to x3 of t square. Now x3 of t square is replaced by a x1 of t plus b x2 of t. Okay, a x1 of t square plus b x2 of t square. A x1 of t plus b x2 of t, that constant. Second step, y3 of t should be equal to a y1 of t plus b y2 of t. A y1 of t is equal to x1 of t square plus b y2 of t equal to x2 of t square. Equation number 2. So let's say this is equation number 2. So 1 and 2 both are equal, therefore it is linear system. Okay. After y3 x3 relationship, then x3 of t replaced by ax1 plus bx2. So here y of t equal to x square of t. Y of t equal to x square of t. Y1 of t equal to x1 square of t. Y2 of t equal to x2 square of t. Y3 x3 square of t. Now x3 replaced by a x1 of t plus b x2 of t, and then this square represent and then this square. Okay, x3 square of t. After replacing your x3 equal to a x1 of t plus b x2 of t, then you have to take the square. This is equation number 1. Then the output of the system y3 should be equal to ay1 plus by2 of t. So in this problem, y1 of t equal to x1 square of t, y2 of t equal to x2 square of t. So see here, a plus b whole square. If we expand this, a square x1 square of t plus b square x2 square of t plus 2ab x1 of t x2 of t. So in this example, 1 is not equal to 2. Therefore, the system is non-linear. Okay. So while solving the problem, it should be clear. X of t square is different from x square of t function. Okay. So x of t square, linear, non-linear. Sorry, time invariant and time variant. Which one is time invariant? Which one is time invariant? Static dynamic we identified. Causal, non-causal completed. Linear, non-linear we completed. So x of t square, x square of t. Identify whether it is time variant or time invariant. What is the step to identify time variant, time invariant? Assume our output of the system is delayed by t amount of time. So in this expression, wherever small t is there, all the small t replaced by t minus t. Equation number 1. Now, output of the system due to delayed input. So wherever x of function available, x of t square is the function. Now that is delayed by t amount of time. 1 is not equal to 2. This is t minus t square. Here the input is delayed by t amount of time. Therefore, it is time variant system. So in this example, output of the system delayed by t amount of time. In the y of t expression, if small t replaced by t minus capital T, in the entire equation, wherever small t available, you have to replace the small t by t minus t. Second step, y of t due to delayed input. Y of t due to delayed input. So x square of t is the function. So this is delayed by t amount of time. Equation number 2. So equation 1 and 2 are equal. Therefore, it is time invariant system. Okay. So any doubt? Linear, non-linear, time invariant, time variant identification, and little bit difficult. You have to solve the problem or understand the concept. Once you understand the concept, then everything is simple. So more problems are there. Basic problems from example and exercise signals and system by Opanium textbook, which is available in your Google Classroom, and try to solve it. And signals and system by Ramesh Babu, reference book. Unable to get the soft copy of the textbook that is available in the library only. But I am solving problem from the signals and system by Ramesh Babu. Simple problems. So any doubt up to this particular stage? Classifications of system. You may expect theory question also. List out the classifications of signals and system. Explain with a suitable example. Or any 2-3 system they will ask for 4 marks. Definition with example. Okay, so students should be ready either for theory questions or problem based questions. Okay, this is simple. This is simple. Linear, non-linear, little bit difficult. Time invariant, time variant also you have to do carefully. Please let me know any doubt up to this particular stage.